Hi, everyone. Thanks for joining the webinar today. I'm Jason Bedreau, Vice President of Marketing at NetBrain. I'm joined by David Femino, a solution architect at NetBrain, who will run a live demo for us in a little while. Today, I want to talk about something that every business probably cares a lot about: mean time to repair, because this is an important measure of how effective IT teams are at keeping the lights on and keeping the business running. So every day, operations teams face intense pressure to resolve incidents, which keep on coming. Responding effectively is perhaps the most important role of network operations. Network incidents impact revenue and reputation, and typical enterprise networks are managed with a suite of event management and incident management solutions, like SolarWinds, Splunk, and ServiceNow, which generate alarms and tickets requiring attention. A large network can easily generate thousands of alarms and hundreds of tickets every day, each one requiring some manual human intervention. I'll pause here and take the opportunity to ask the audience, what kind of tools are you using for monitoring, security alerting, and incident management? We'd love it if you would use the Q&A panel to respond. Also, feel free to let us know if you have any metrics around the volume of alerts or tickets your organization is receiving every day. A member in the room here with us of our organization will chat with you on the chat window over there to try to get more information from you. So we'd love it if you'd respond. All of those event management tools are critical to tell you there's a problem. If you don't have one of those, you don't have a smoke alarm. But when it comes to firefighting, the troubleshooting response is still very manual, even today. The primary troubleshooting tool is the CLI, the command line. In fact, it's the only tool used for troubleshooting in about 75% of the cases from some of the studies that I've read. So what's wrong with that? It's been working for decades. Why do we need troubleshooting automation all of a sudden? It's really about the scale and complexity of today's infrastructures. You can get a lot of information from CLI digging, but I've outlined 3 key questions and 3 key areas which CLI won't address. The first, what changed? This is usually the first question you ask. It was working yesterday, so what happened? To answer that, you need history data, which you can't get from CLI. Second question, is this normal? To understand that, you need to have your network regularly baselined. You can't get baseline data from CLI. It's a snapshot of a moment in time. And what should I do next? Troubleshooting outcomes are highly unpredictable because it depends so much on who's responding and depends on their experience. So those 3 questions are at the center of a typical troubleshooting workflow. But let's look at an incident response framework more broadly as a way to identify where time is wasted and to identify opportunities to be more efficient during a troubleshooting response. When there's an incident, often initiated from a network alert, security event, trouble ticket, it takes some time before the first engineer arrives on the scene. That first response is typically a junior support staff, and he or she will perform a set of common checks, usually through some manual command line digging. If the problem can't be resolved quickly, it's quickly escalated to bring in a team with more experience and more subject matter expertise, until ultimately the problem is identified and the incident is resolved with some remediation steps. But what's perhaps the most important part of an incident response is often overlooked. This is the post-mortem review. It's where that question, can we do better next time, is asked. Capturing lessons learned in this phase is one thing, but sharing those lessons and using them the next time a similar problem happens has always been the challenge. You can break down this whole workflow into 2 main sections, what I call TTI and repair, where TTI can be the time to identify the problem, or perhaps more likely the time to innocence. Okay, so let's look at opportunities for automation within this framework to identify how teams can become more effective and more efficient. So one obvious place for automation is at the very beginning, the moment an incident occurs. If you could connect a diagnostic automation solution to your existing incident management or event management tools, then a just-in-time diagnostic could occur at the instant of that event. The next opportunity for automation is to augment the first response, team response, or remediation procedures. This replaces the manual methods with automation tools for diagnosis. This is basically like replacing a manual drill with a power drill. And the most important place for automation is at that very end, when you're doing the post-mortem analysis. You've identified the smoking gun, you have the root cause. More than just documenting that listen, what if you could easily create an automated diagnostic that checks for that problem the next time there's an incident? That enhanced automation would be part of a feedback loop, effectively shifting knowledge to the left as a tool for the first response engineer, but also as a tool for that automated first response before a human arrives in the scene. This would enrich the system's ability to automatically capture the problem, or at the very least rule out a known issue the next time there's an incident. So NetBrain is designed to augment a typical incident response workflow like this one, with two things, with mapping and diagnostic automation. To do that, NetBrain first creates a data model of the network's control plane logic. Through a deep discovery, NetBrain identifies the network's inventory and topology, but more than that, its underlying design logic across layer 2, layer 3, and layer 4, so that a dynamic map can be used to visualize any part of that data model. So each dynamic map in NetBrain is created instantly to help define the scope of an incident. In the example in the image here, a source and a destination of a slow application was defined as two endpoints, and the path was dynamically created. So that map is then used to visualize any data about the network that can be useful for that incident. Topology data, configuration and design, baseline data across thousands of data points, even data from third-party solutions that have been integrated with NetBrain. A dynamic map is the user interface for then driving that automation. The tool for that automation is called the executable runbook, and it's used to codify operational knowledge within an organization. As teams resolve each outage, their tribal knowledge naturally is growing. That knowledge can be documented in a runbook. And perhaps more importantly, as the name implies, these runbooks are executable. The automation is built with simple drag and drop programming, and that automation scales across any network and any technology. The idea is write it once and execute it anywhere on the network. So going back to that automation framework, I'll bring in David Femino to the proverbial stage here to run a live demo of NetBrain automation. David will use dynamic map and executable runbook at each phase of this workflow. David?
Thanks for the great intro, Jason. Now let's take a look at each phase of the reference workflow and see how NetBrain can scale for any challenge and adapt to any workflow. So let's start with the first response automation. How often do we see an incident gets reported just for it to sit in a service desk queue with no actions being taken? All the while, the problem could be getting worse or everything clears and it's difficult to determine the root cause. With NetBrain's first response automation, your ITSM and monitoring solutions like ServiceNow, Remedy, SolarWinds, PRTG, and Splunk, just to name a few, can trigger NetBrain into action and automatically map the problem area and run diagnostics the second the issue has been detected. But it's not just for problems. NetBrain can also begin the process of collecting information for any task on any network. These findings are documented in a single map that everyone can access at any time. Let's see a few examples. Let's jump into my ITSM system where I keep track of all of my tasks. Here I have 3 tasks listed for me, and let's see how NetBrain is able to help me with our first response automation. This first incident is telling me that I need to verify the site design for our Boston location. And within the ticket, we configured a device to link into NetBrain, in this case US Boston Router 1. What NetBrain is doing here now is taking a site map where that router has been configured for, and now is going to create that map for me. So within my map, now I have all of my switches, firewalls, and routers, and all the connections back into various MPLS clouds. NetBrain has also executed a runbook on top of this map. One example is that I'm executing CLI commands. So I have show interface and show version for all of these devices on my map. I also have an overall health monitor just to give me a quick health check on all of the devices within my Boston site. And then I also have a brief OSPF design across my Boston site, as well as BGP configuration within this site as well. That's so awesome. NetBrain was able to help build out this map for me, so I don't need to worry about finding all of the devices in Boston. It's already been created for me. Let's jump back to my task list. The second task I have is verifying VXLAN design. So let's see how NetBrain is going to help me build out this map. If we scroll down through our incident, I can see that there's been a source and a destination, 192.168.1.1 and 192.168.1.2. Let's take a look at the map that NetBrain has created for us. When I open up this path, I'm going to see that we have all of the devices between that source and destination. Now keep in mind, this was also a VXLAN path, so I want to be able to view all of the different connections, the overlays and underlays for this path. So let's take a look at how NetBrain is able to draw out this path. We have our source and destination, and it's just looking like a straight path, but I can then click and toggle between all the different paths. So I can put my layer 2 underlay, I can have different overlay information, and I can dynamically build out this path any way I want it. Right? And ultimately, I'm able to see all of the devices along this path and see how they all work together to make the source and destination seamless. So that's great. I didn't even need to worry about adding devices. This path was built out for me. And finally, let's go back to that list of tasks and let's look at the last one, poor video quality. So let's see how NetBrain is also going to help us in this example. Once again, we have a source and destination IP address put into the incident. So this notifies me that NetBrain is going to build out a path. Let's check out this path. Now, in this scenario, we actually have a specific problem that we're looking to correct. And this one was choppy video quality. So like the previous path, I can see all of the devices that make up this traffic, including Palo Alto firewalls and F5 load balancers. But let's focus a little bit more now on the runbook that was executed. We ran an overall health check like we saw earlier to just give us a quick overview of our entire network and see the health of our network. But in this time, because of the incident that we've defined, we also want NetBrain to start pulling QoS information and also policy and class configuration. And I can review all of these results just like I was able to before. So these three examples showed us how NetBrain was able to automate the map creation and in many cases also automate the initial triage and diagnostics collection, allowing us to be able to visualize and review this information instead of spending a lot of time collecting the information. Everything we've seen so far with NetBrain's first response automation helps us with building out specific maps automatically for any task. Let's focus on how easy it is now to build out these maps on our own, dynamically, in real time. Whether it's for dynamic documentation with Layer 3 and Layer 2 topology information, or just trying to understand network design throughout your enterprise network. With NetBrain's first engineer automation, we'll see how easy NetBrain can help us accomplish these tasks, and also see how NetBrain is a true companion of CLI, and how NetBrain's automation can save time and provide a deep dive into historical data. So let's see how NetBrain knows everything about our network. Let's start by looking at the number of devices that NetBrain is aware of. In this case, we see that 160 devices have been discovered, and that they range from routers, switches, to firewalls, and load balancers. Within NetBrain, I can search through all of those discovered devices, and I can search for device host names, configuration text, or IP addresses. In this example, let's take a look at it searching for New York City. Here I see a list of all of my devices that match New York City in the host name, as well as the configuration file. If I take a look at some of the information NetBrain has collected, I can see serial numbers, the model numbers, management IPs, software versions, and also configuration files, ARP tables, and various other data tables. But let's start by building a map. I can drag and drop this device onto my map, and now NetBrain has started the map process for me. When I click on the plus sign to extend neighbors, I can add more devices. In this case, I'm adding layer 3 neighbors. NetBrain will add these devices dynamically to my map, and I can see I have a switch, a Palo Alto firewall, and now an F5 load balancer. I can also add layer 2 neighbors and add a couple more devices to our map. NetBrain is adding all of these devices dynamically, And I can move these around. And if I zoom in a little bit more, I'm going to get some routing protocol information, as well as interface speed and duplex, as well as VLAN mode. Now, we saw how easy it was to search for a device and build out that map. Let's see how easy it is to build out a path on demand as well. I click on the path button, I can put in a source and destination IP address or host name, as well as a TCP or UDP port, and let's see how quickly NetBrain is able to map out this A to B path. In this example, I can see that this path is going from a video server through a Cisco switch, an ASA firewall, a pair of Cisco routers, a Palo Alto firewall, and finally through an F5 load balancer. All along the way, NetBrain is calculating the correct information and adding these devices to my map. Along the way, on the Palo Alto firewall, I can see that a specific policy was permitting traffic to our destination. And in the F5 load balancer, I can see the virtual IP translation to my 3 end systems here. Now, once we've built out this map, I want to be able to toggle between different layer 3 and layer 2 underlays. Just like we saw on the other map, I'm able to add now my underlay and see this layer 2 switch along my path. I can add it back or remove it dynamically as I please. Now, a concept I want to introduce now is a dynamic data view, or an overlay of information. This dynamic data view panel is what we call a knowledge tree. And we call it a knowledge tree because all of the information and data and knowledge that we've collected from our network and from our engineers can be listed here. So each of these knowledge tree overlays is going to help us understand our network. So for example, if I run the overall health check, NetBrain is pulling in cache data that is helping me understand the live information about my network. So I'm seeing CPU and memory utilization, as well as interface details. And also I can see on my firewall that I have the failover state. If I zoom in, I can see more or less information. In this case, I'm seeing MTUs, input errors, output errors, etc. This highlighted in red, this output errors of 10, is notifying me of a baseline alert. New to NetBrain, we have this concept of a golden baseline. This baseline is detecting what our network should look like based on historical data. And in this case, our baseline is telling us that the output errors should equal 0. Any anomaly outside of that is going to trigger this alert. This alert doesn't necessarily mean that there's a problem. It's just telling me that there's something different and something outside the norm. And just like before, I can toggle between all of my different input errors and interface errors and see the historical data over time. You may have noticed in the upper left that this is also showing me cache data. If I click on live information, NetBrain is going to log into each device to pull this information in real time. Right, so I'm going to be able to compare this data from historical times to the live data. Now, I've noticed that a lot of engineers spend the majority of their time collecting data as opposed to actually analyzing the data. With NetBrain, we're hoping to flip that script and help you use most of your time being able to analyze the data as opposed to having to collect it. And now we are looking at the live data. What I can also do now is overlay some more information on top of this map. So in this example, maybe I want to take a look at OSPF information. If I overlay the OSPF information, I'm able to see how many neighbors we have, how many OSPF interfaces, the processes, and global routes. And just for good measure, I can also add the OSPF configuration as a sticky note on this map. And then the final example, I have a QoS overview. So again, I can use NetBrain to help me understand this network's design and understand how QoS has been configured on this map. So I'm highlighting devices that have QoS, and I can see that there's been 1 service policy created, as well as 6 class maps and also 25 ACL rules. Everything that we've seen so far is going to help me troubleshoot my network faster. But now let's introduce the concept of the runbook. The runbook on a map is capturing all of the actions that I'm performing against my devices. So we ran the overall health check, we ran the OSPF, and we ran the QoS overlays, and now I can also see the results. I can add other information to this map as well, such as executing CLI commands. So we talked about how NetBrain can be a true companion of CLI. So now if I enter in show interface, NetBrain is going to log into each device, issue that command, and return the full output. We can do this simultaneously across all of our devices and be able to see this information, again, collected in real time. In addition to just displaying the full output, NetBrain is also parsing out this information. So we have a team of network engineers that have identified some of the most commonly used variables out of the most commonly used show commands. So for example, I can see the number of input errors is highlighted by this variable. And if I want to, I can tell NetBrain to monitor these specific variables at set points in time, every 2 minutes, or I can set whatever frequency I want it to be. And NetBrain can notify me if any of these variables falls outside of the threshold that I've set. The next phase in our reference workflow focuses on escalations. And here we want to see how we can use the NetBrain dynamic map as a user interface for all collaborations, whether it's between members on the same team or whether it's escalating between different teams. We'll also see how the NetBrain executable runbooks are able to share this knowledge and share these activities and reduce the amount of overhead and duplicate work that needs to be done when an incident or task gets escalated on. When a map gets escalated to me in NetBrain, I'm going to receive a notification in my toolbar. This notification is telling me that somebody mentioned me in a runbook, and it gives me the map name. When I click on this map, NetBrain is going to open up the map and also bring me directly to this runbook where I was mentioned. Now, what I can see here is that somebody mentioned me and said, can I take a look at routing in New York City? We're having a lot of problems. Right away, this user has been able to narrow down my focus and is telling me specifically to look in New York about a routing problem. They were also able to mention the specific device and mention the table. So now instead of me needing to go into a specific router and searching for the routing table, this hyperlink is going to provide me with that information right away. And here I can see I have the routing table from 10.8, and I can toggle between historical data or live data. I can also export this routing table as well. If we have different VRF configurations, we can toggle between that as well. But you can see just how easy NetBrain's escalations have allowed me to narrow down into the specific issue. But just by looking at this routing table really isn't going to help me too much. So now let's take a look at what other actions this engineer has completed on this map, and let me review that. Remember when we created activities within the map, we were able to see how NetBrain created that activity in a runbook? Well, here I'm able to review all this information that this engineer performed as well. I can see that they ran a couple CLI commands, specifically show IP route, and I can toggle between all my different devices to see that information as well. Now, this is also going to be logged at the time that this engineer collected this information. So if I need to, I can run this information again. I'm going to have now 3 different results, and I can use NetBrain to compare that. I can also see that the engineer ran a couple overviews. He ran an OSPF overview, as well as a BGP overview. Right, every time I click on this result, I'm able to see this information displayed on my map. As I zoom in, I can see the number of BGP neighbors, the filters, and also additional BGP information. These are the same data views that we saw earlier. But now what I want to focus on is the ability to share recommended actions. Remember, this is now a tier 2 team that is really responsible for these routing configurations. Within NetBrain, I can also identify recommended actions based on the previous steps that have been performed. When I click on recommended actions, I can see that I have 4 actions recommended to me. I have a compare node, another show log, I have a troubleshooting BGP hyperlink, as well as another data view of an IP BGP prefix instance. Each of these I can add to the runbook. In this case, run the IP BGP. NetBrain is going to log into these devices and collect this BGP information for me. I can also see now there's an add to runbook the compare node. I want to be able to compare additional information within NetBrain as well. All of this information is going to get added into this runbook and saved with this map. So as I save this map, the previous engineer can review everything that I've done, as well as I can share this information with another tier of engineers if I need to escalate it further. Collecting all of this information has helped me diagnose this problem even further, and what I want to do is maybe I want to export this map to Visio. Saving all this map with the data view information applied, I can export to Visio. I can also export all of this information into a Word document, from topology information all the way down to specific data view information that I've collected related to BGP. For the next stage, we're going to focus on remediation automation, or in other words, how we can make and execute changes within NetBrain. Now, whenever we want to make a change, we always have several risk factors we need to consider. First off, when are we going to execute this change? What is going to be impacted by this change? And also, is this change necessarily going to help solve the problem? As we review all of this information, there are going to be complex and critical configuration items that we need to make towards each device. And with NetBrain, we can use the map as our change interface to not only identify the scope of the devices we wish to execute these changes against, but also use NetBrain's executable runbooks as a way to verify the impact of that change. And if there's been an error with the change execution, identifying that a lot sooner before it becomes a bigger problem than we tried to correct in the first place. To showcase NetBrain's change automation feature, I'm going to leverage a pre-existing change that has already been executed. Let's take a look at what we can do. To get started, I can see that Chris has created this change request, and it's going to change a QoS policy on a router to correct a video performance issue. To get started, we want to first define the change, and we can see that Chris has defined a policy map and transmit rate to make sure that we're correcting this issue. We can see that here. Once we've defined the change, we need to get it approved, right? We don't want to just go making changes at any time that we want. So what we're able to do now is push this change into our change management console, in this case, ServiceNow. Once this change is pushed into ServiceNow, it can follow our normal approval processes that we have through ServiceNow. Once it gets approved, I'll be able to execute this change within NetBrain. We can see the status here that it was approved, etc. Before I make the change, I want to take a snapshot of all of my devices on this map, specifically US Boston Router 1. So I'm taking a snapshot of all these devices, and then I'm going to execute the change. And here we can see that US Boston Run did have this change executed. Now in this example, I'm only making a change on one device, but you can see how NetBrain's change management functionality can scale to hundreds of devices at a time. After we've executed the change, I want to collect my configuration file again. If I know specifically where I want to look, I can see and verify that QoS policy has in fact been changed. But we're all about automation here at NetBrain, so let's take a look at automating that comparison function. I can see that for US Boston Router 1, NetBrain is bringing me directly to that line item where this change has occurred. And I can verify that this has in fact been successful. If I needed to make an edit, I could go back to the change and configure a rollback and push back basically a negation of the change in the QoS policy. We can change specific configurations on different items, and we can also blanket change to all devices if we so choose. There's a lot of flexibility with NetBrain's change automation. For the final piece in our reference workflow, we want to focus on proactive automation. This will take all of our lessons learned from the activities along our journey and make improvements for the future. In many cases, network issues are repetitive, but rarely are the solutions documented. So when our issues arise, the next time, the team has to start over from scratch. The knowledge that resides in a senior member's head is not always there to be shared and updated. So we want to take these lessons learned and constantly improve our first response automation and better equip the runbooks and tools that the engineers have at their disposal. This will help us resolve incidents much faster next time. Our goal is to shift the workload to the left and continuously improve the NetBrain system to drive forward the next level of automation. Let's go back to one of the paths we looked at earlier. The key knowledge drivers we want to look at in NetBrain are the data view templates and runbooks. Remember that data views can overlay rich amounts of information based on network design, running technologies, and much more. So if we want to see OSPF information, we'll click on the OSPF data view, and quickly we can see the number of neighbors, interfaces, routes, etc. Now, let's see how we can take what we've learned from a previous incident and improve upon this data view. To the right of each data view information is a drill down arrow. This contains follow-up actions that we can recommend based on the protocol we're looking at and also from previous lessons learned. Here, somebody is recommending that I should perform a ping as well as execute some CLI commands, and I have the option to add each to my runbook. When I select the CLI command, you can see that the entire CLI command is populated for me for quick retrieval. I can add notes to this runbook as well if I want to collaborate with my team members and be able to comment specifically on these CLI commands or actions in these runbooks that we're performing. But let's see how easily now we can change a data view template. Let's go to our data view template manager, and I'm going to click on the OSPF data view. In the OSPF data view, I can see there's drop-down menus. I can choose any of the over 12,000 variables that NetBrain has identified and add that information to an interface level or to a device level on my map. I can choose specific drill down actions for each of these variables, as well as add drill down actions to the entire data view as a whole. As you can see here, the data view for OSPF has a compare, a show log, and also a troubleshoot OSPF link. You can add both internal and external links to a drill down action. And in this case, if we had a knowledge article we wanted to link to, we could include that in our data view so that each of our engineers will be able to find that information when they need it. Let's go back to the map. If we had edited one of those drill down actions, the recommended actions would now be shown here, including that link to an external or internal source. The other thing we want to update is the runbook template. So as we've been going through this demo today, all of our actions have been documented. As I add more and more to the runbook, this is going to improve our runbooks for the future. So let's save this as a template, and I can choose the nodes that I want to save, and then I can save it for each of my teammates to be able to share and see at another time. So that does it for our quick overview of how we can improve both our runbooks and data views based on the lessons learned. Back to you, Jason.
Thanks, David. In order for automation to provide value for every incident, every day, and continuously drive down mean time to repair, it has to scale in 3 ways. First, it has to scale to adapt to the unique needs of every issue. The very nature of troubleshooting is reactive, right? You don't know what devices are going to have a problem or the sequence of steps to troubleshoot a given issue. So automation must adapt and evolve to provide guidance for any issue. Second, it has to scale to any size network. Troubleshooting is like finding a needle in a haystack. Finding that needle in an enterprise network means scaling to support thousands of devices across potentially hundreds of sites. Last, it has to scale to fit the complexity of modern networks, typically involving many vendors across routing and switching, security fabric, load balancing, SDN, SD-WAN, and more. So in other words, to materially reduce mean time to repair, automation must scale for any type of issue across any infrastructure, regardless of its complexity. And up to now, this has been a very big challenge. And we're seeing new technologies like SDN and SD-WAN make that challenge to troubleshoot even greater. It's because the knowledge gap a new and unfamiliar technology introduces, and also because of the complex nature of networks becoming more hybridized. Teams must figure out how to map traffic flows across that heterogeneous environment, representing different vendors and technologies, so the tactics within a troubleshooting workflow become more and more challenging. To scale automation across a heterogeneous network, the NetBrain data model is capable of absorbing data from different types of data sources to represent it in a single, consistent view on a dynamic map. So in the case of Cisco ACI, as a common example, gaining adoption, NetBrain discovers that infrastructure from the 8-bit controller, the SDN controller, via API. It augments that with data collected from the traditional network via SSH and SNMP. The output is a map of the heterogeneous network, including the ability to map traffic paths across it and to run diagnostics across it. The ultimate vision is to drive more and more automation into the time-sensitive workflows like troubleshooting, so network teams can spend less time firefighting and more time designing and implementing new business functions. On the left side, you have what I'd call status quo troubleshooting, done manually by humans. On the right side, you'll have what some people refer to as a self-healing network, which is capable of identifying problems and repairing itself. So for the purposes of this illustration, I created some examples of what a journey from left side to right side might look like with a NetBrain implementation. First, what I'll call level 1 automation. This introduces automated documentation with dynamic map and augmented troubleshooting with built-in runbooks. This can be achieved virtually out of the box with NetBrain. Level 2 automation absorbs knowledge from your organization's existing playbooks or knowledge base and codifies them into runbooks unique to your team, providing what we referred to earlier in the presentation as interactive automation. Level 3 takes those custom runbooks and integrates them into your existing incident response or monitoring solutions. So this way, a custom diagnostic can be conducted at the moment an incident occurs. In some cases, the root cause may be identified automatically. In other cases, this may rule out many possible causes, still saving a lot of time. Finally, level 4 automation represents an ideal or aspirational state, where virtually all possible issues are well known and well documented, each with a corresponding custom diagnosis. That custom diagnosis could be executed automatically at the moment each event occurs. So I described this journey from left to right not as a step function which can be solved pointedly by a single solution, but as a continuous journey achieved by implementing a methodology for continuous MTTR reduction and aided by automation. So that concludes our webinar today. If you're an existing customer of NetBrain with an active maintenance or subscription and you're not yet running NetBrain 8.0, then I strongly encourage you to request your upgrade today. You can do that by visiting netbraintech.com/request-8-0-upgrade. We'll include this link in a follow-up email with a recording of today's webinar as well. So we'll stick around after this call for questions over the phone for a while. So please keep those questions coming over the Q&A panel. We'll be responding to those via chat. And in many cases, thinking that those questions are relevant for the broader audience, taking those questions out loud over the phone as well. So please do keep those coming. Otherwise, thanks again, everybody on the call, and please have a great day.